Good morning, sir. Good morning, classmates. I am Claudelle Racines.
I am Pestano.
And I am Marciene Raymundo.
And we are the Group 3. For our learning objectives, number 1, list the steps of the decision-making process. Number 2, describe the types of decision-making environments. Number 3, make decisions under uncertainty. Number 4, use probability values to make decision under risk. Number 5, develop an accurate and useful decision trees. Number 6, revise probability estimates using Bayesian Analysis. Number 7, use computers to solve basic decision-making problems. And number 8, understand the importance and use of utility theory in decision-making. The success or failure of a person depends on the decision he makes. Every decision can make a difference between a successful career or an unsuccessful one. So decision theory is analytical and systematic approach to the study of decision making. The difference between good and bad decision is that good decision is based on logic. It considers all available data and possible alternatives and applies quantitative approach. Some results may have unexpected or unfavorable outcomes, but since it is done or it is made with good decision, still it is a good decision. So there are 6 steps in making a decision. So these steps, we can use this kahit sa maliit na bagay. Even if gusto mo lang magpagupit, magbili ng bagong cellphone, or start a business. So the first is clearly define the problem at hand. Next, list the possible alternatives. Next, identify the possible outcomes or state of nature. Next is list the payoff or profit of each combination of alternatives and outcomes. Then, select one of the mathematical decision theory models. And lastly, apply the model and make your decisions. So, in order for us, para mas magtindahan natin, let's use Thompson Lumber Company as an example. So, Johnson Thompson is the owner of the lumber company. This is a profitable firm. So, number 1, he identifies whether to expand his product line by manufacturing and marketing product or backyard storage sheds. So, number 2, he generate the alternative available to him. So, in decision theory, alternative are those action or strategy that a decision maker can use. So, Thompson decides that his alternatives is to construct large new plant, small plant, and no plant at all. So, those are the 3 alternatives available. Number 3, sometimes the common mistakes is that we forget kung ano yung mga possible outcomes because we think it is light or wala siyang value. But sometimes yung mga bagay na yon, they become the best choice. So, sa optimistic decision maker, dito, in-ignore nila yung bad outcomes. While pessimistic managers, they may discount favorable outcome. So, if you don't consider kasi all possibilities, then you are not making a logical decision. Therefore, you're not making a good decision, and it may result to an undesirable one. So, dito sa number 3, he determines only 2 possible outcomes. The markets should be favorable, meaning high demand for product. And second, unfavorable, meaning low demand for the sheds. So for step 4, since Thompson wants to maximize his profits, he can use profit to evaluate each consequence. So for step 5 and 6, these last 2 steps is to select decisions model and to apply it to the data to help make a good decision. So in selecting models, it depends on the environment in which you are operating, the amount of risk, and the uncertainty involved. So in the next slide, you will see the decision table with conditional values for Thompson lumber. Let us now proceed to the types of decision-making environment. Every person or every type of decision that a person makes depends on the knowledge or information they have on the situation. So now, we will talk about the environments or the three types of decision-making environments. So for number one, decision-making under certainty. In this decision or in this environment, decision makers have the uncertainty to the consequences of every alternative or decision choice. In this type of environment, decision is usually relatively straightforward. So dito, they will choose the alternative that will maximize their well-being or will result in the best outcome. Number two, decision-making under uncertainty. So there are several possible outcomes for each alternative, and the decision maker does not know the possible or the probabilities of the various outcome. So in this type of environment, the probabilities are not known. And lastly, number three, decision making under risk. So in this type of environment, there are several possible outcomes for each alternative, and the decision maker knows the probability of occurrence of each outcome. So between two extremes of certainty and uncertainty lies the case of risk. So in this environment, unlike under the uncertainty, in under risk, probabilities are known. So again, decision-making under uncertainty. So when a manager cannot assess the outcome's probability with confidence or the probability data are not available, the environment is called decision-making under uncertainty. So there are 5 criteria exist for making a decisions. These are the Maximax, Maximin, Criterion of Realism, equally like Minimax Regret. And the first 4 criterion or the first 4 criteria can be computed directly from the decision payoff table, while the Minimax Regret requires use of opportunity use or opportunity loss table. So in order for us to understand it well, let's use again the Thompson number as an illustration. So for number 1, Maximax, it is used to find alternative minimizes the maximum payoff. So first is you should locate the maximum payoff for each alternative and then pick the alternative with the minimum number. So in Maximax, we determine the best possible payoff. So in Maximax, it is used or the approach used here is the optimistic approach. Optimistic approach because the go for it strategy is used and it does not take into account any payoff other than best. So in the table, we can see that Thompson's Maximax choice is the first alternative, which is construct a large plant with the maximum of the maximum number within each row. So number 2, Maximin. So Maximin is used to find the alternative that maximizes the minimum payoff. So dito, we should locate first the minimum payoff for each alternative, then select the alternative with the maximum number. So here we determine the worst possible payoff or the best of worst. So kanina sa Maximax, we determine the best possible payoff. Dito naman, the worst possible payoff. So the approach used here is the pessimistic, since it only takes into account the worst possible outcomes. So in the table, do nothing is shown since this decision is associated with the maximum of minimum number within each row or alternative. Both Maximax and Marciene consider only one extreme payoff for each alternative, while the next criterion we will talk about considers both of these extremes. So the third criterion is the criterion of realism. So in this criterion, it uses weighted average and it compromises optimistic and pessimistic decision. So to begin with, select a coefficient of realism. So coefficient of realism, it measures the degree of optimism of the decision maker. It is between 0 and 1. So when the value is 1, decision maker is 100% optimistic about the future. While if the value is 0, the decision maker is 100% pessimistic about the future. So the advantage of this is that the decision maker is allowed to build a personal feelings about relative optimism and pessimism. So always remember that when the coefficient realism is 1, it is same as the optimistic criterion. While if it is 0, it is pessimistic criterion. So each alternative is computed and then the highest weighted average is chosen. So if we assume that Thompson set his coefficient of realism to be 0.8, then the best decision would be construct a large plant. So as you can see in the figure, this alternative has the highest weighted average, which is $124,000. So it was computed by 0.8 or 0.8, the coefficient alternative, times 200,000, and then later on added by 0.2 times 180, and the result would be 124,000. So since there are only two states of nature in this example, these two payoff for each alternative are both considered. But if there are more than two states of nature, then all payoffs will be ignored except for the best and worst payoff. So for the next criterion, all possible payoffs for each decisions are considered. So this criterion is called the Laplace or the equally likely. So in this criterion, it uses average outcome. It involves finding the average payoff for each alternative and selecting the alternative with the highest or base average. So Laplace treats the states of nature as equally likely. And as you can see in the figure, the equally likely for Thompson number is the second alternative, which is construct a small plant. So for our last criterion, the Minimax Regret, Minimax Regret is based on opportunity lost or regret. Opportunity lost or the opportunity loss refers to the difference between optimal profit or payoff for a given state of nature and the actual payoff received for a particular decision. In this criterion, it determines the worst regret for each alternative and choose the alternative with the best worst. So in the figure, for favorable market, the best payoff is $200. As a result of the first alternative, construct a large plant. If the second alternative is selected, a profit of $100 would be realized in a favorable market and is compared to the best payoff of $200,000. Thus, opportunity loss is 200,000 minus 100,000 equals to 100,000. Similarly, If do nothing is selected, the opportunity loss is 200,000 minus 0, which is equals to 200,000. So in unfavorable market, best payoff is $0 as a result of the third alternative, do nothing. So this has zero opportunity lost. The opportunity losses for other alternatives are found by subtracting the payoffs from this best payoff in the state of nature as shown in the table. In using opportunity loss or the regret table, first is find the maximum or the worst opportunity loss for each alternative. And then look at the maximum values and pick the alternative with the minimum or best number. Hence, the opportunity loss actually realized is guaranteed to be no more than this minimax value. In the table, we can see that minimax regret choice is the second alternative, which is to construct a small plant. So since we are done considering several decision-making criteria, and I hope you understand it, we can now proceed to the next decision-making environment. So for the next decision-making environment, let's give the floor to Keith Pestano.
These decisions are simple in manner, but when there are many possibilities to take that decisions at that time, risk occurs. Today, we know that people make decisions after the well-deliberated calculations. Here it comes the decision making and the risk. It is when there are several possible states of nature and we know the probabilities associated with each possible state. So most popular method is to choose the alternative with the highest expected monetary value. The formula of expected monetary value is equals to P of the first state of nature multiplied to the probability of the first state of nature plus payoff of the second state of nature times probability of the second state of nature, and so on. Expected value of perfect information. It is the price that is willing to pay to gain access to perfect information. So the formula of expected value of perfect information is equals to expected value with perfect information less maximum expected monetary value. But before we can solve the expected value of perfect information, we need first to get the value of expected value with perfect information. So the formula of expected value with perfect information is equals to best payoff for the first state of nature times probability of the first state of nature plus best payoff for second state of nature times probability of second state of nature plus best payoff for the state of nature times probability of the last state of nature. So let's apply the given formula. So expected monetary value for large plant is equals to 0.5 times 200,000 plus 0.5 times negative 180,000 is equals to 10,000. Then expected monetary value for small plant is equals to 0.5 times 100,000 plus 0.5 times negative 20,000. Then the answer is 40,000. Last, the expected monetary value when we do nothing is equals to 0.5 times 0 plus 0.5 times 0. Then the answer is 0. As you can see on the example, alternative small plant has the highest expected monetary value. Again, let's apply the formula given. So if the best alternative for favorable state of nature is to build a large plant with a payoff of 200,000, then best alternative for unfavorable state of nature is to do nothing with a payoff of 0. So, i-apply na itong formula sa expected value with perfect information. So, 200,000 times 0.5 plus 0 times 0.5 is equals to 100,000. So, nakuha na nato ang amount sa expected value with perfect information. Then, i-solve na nato ang expected value of perfect information. So, again, ang formula is EVPI is equals to expected value with perfect information, which is 100,000 less maximum EMV. So, ato na siyang i-solve. So, 100,000 less 40,000 is equals to 60,000. So, therefore, they need to pay maximum of 60,000 for the additional information. Expected opportunity loss, or EOL, is the cost of not picking the best solution. So, ang formula on getting EOL is same as formula on getting expected monetary value. The only difference is in expected monetary value, the highest payoff was being selected, while in expected opportunity loss, or EOL, the lowest amount was being selected. Now, let's proceed to the decision trees. This representation below is characterized by a tree-like structure in which the problems in decision making can be seen in the form of flowchart, each with branches for the alternative choices. This analysis is commonly represented by lines, squares, and circles. The squares represent decision, the lines represent consequences, and the circles represent uncertain outcomes. By keeping the lines as far apart as possible, there will be plenty of space to add new considerations and ideas. So let's proceed to the example of a decision tree. So as you can see, kabalo ko familiar na taning tanan, natudo na siya sa to before. So karon explain na ako kung paano nakuha ang 106,400, 2,400, 40,000, and 49,200. So nakuha ang 106,400 by adding the product of 0.78 times 190,000 and 0.22 times negative 100,000. Same lang sila formula sa pagkuha sa 2,400 and 40,000. Also, nakuha ang final answer na 49,200 by adding the product of 106,400 times 0.45 and 2,400 times 0.55. Therefore, Thompson will seek marketing information because, based on analysis, it is the best choice.
At this moment, we will be discussing on how probability values are estimated by Bayesian Analysis, as per calculating revised probabilities and potential problem in using survey results. So, Bayesian Analysis is a statistical paradigm that answers research questions about unknown parameters using probability statements. So, there are many ways of getting probability data. It can be assessed based on management's experiences and intuitions. And also, it can be derived from historical data and can be computed using Bayes' theorem. So, Bayes' theorem incorporates initial estimates and information about the accuracy of the sources, where it recognizes that a decision maker does not know with certainty what state of nature will occur. And also, Bayes' theorem allows the revision of initial estimates based on new information. And the revised probabilities are called posterior probabilities. In calculating revised probability, we can use the formula of Bayes' theorem, which is probability of A given B is equals to probability of B given A multiplied by probability of A, all over probability of B given A multiplied by probability of A plus probability of B given complement of A multiplied by probability of complement of A, where A represents a favorable market and B will represent a positive survey. However, there are some other way to simply calculate the revised probability, since the given formula is quite complicated as we hear it. So let's say, for example, we have the given prior probabilities of 0.50 in both probability of favorable market and unfavorable market. And also, we have the conditional probabilities of 0.70 favorable market and 0.20 unfavorable market state of nature on our positive result of survey. While on the negative result of survey, we have 0.30 favorable market and 0.80 unfavorable market state of nature. As you can see on the table, in order to get the positive posterior probability, we just have to calculate first the joint probability, in which on favorable market, we just have to multiply the 0.70 positive conditional probability to 0.50 prior probability, resulting to 0.35 joint probability. And same as true on unfavorable market, where 0.20 multiplied by 0.50 to get the 0.10 joint probability. Next is to add the 0.35 favorable market and 0.10 unfavorable market of joint probability to get the probability of positive survey result, which is the 0.45. Lastly, in order to get probability of state of nature given survey positive, we just have to divide the joint probability and probability of positive survey result, which is 0.35 divided by 0.45, resulting to 0.78 on favorable market. And same as true on unfavorable market, where 0.10 divided by 0.45 resulting to 0.22. Hence, in calculating the negative posterior probability, we just have to follow the same process on how we calculate the positive posterior probability. And take note that we should always get a total of one positive or negative posterior probability when we add the favorable and unfavorable market to get the correct answer. In potential problem in using survey results, unfortunately, we cannot always get the necessary data for analysis in taking some course of action. Survey results may be based on cases where an action was taken, since sometimes when we use survey results, we are basing our probabilities only on those cases in which a decision to take some course of action is actually made. And lastly, in potential problem using survey result, in some cases, conditional probability information may not be as accurate as we would like. Even though, in general, calculating conditional probabilities helps to refine the decision-making process and to make better decisions. Now, we are moving on to discuss utility theory that tackles about measuring utility and constructing utility curve, and utility as a decision-making criterion. So, when we talk about utility theory, the monetary value is not always true indicator of the overall value of the result of a decision, since the theory bases its belief upon individuals' preferences, and also because people make decisions that don't maximize their EMV, or the estimated monetary value. And also, the overall value of a decision is called utility, and rational people make decisions to maximize their utility. So, although at times, the monetary value is a good indicator of utility, there are other times when it is not. This is particularly true when some of the values involve an extremely large payoff or an extremely large loss. So take a look at the figure. Suppose that you are a lucky holder of a lottery ticket, and 5 minutes from now, a coin could be flipped. And if it come up tails, you would win $5 million. And if it come up head, you would win nothing. And just a moment ago, a person offered you a $2 million for your lottery ticket. Let's assume that you have no doubts about the validity of the offer. The person will give you certified check for the full amount, and you are absolutely sure that the check would be good. So, to further explain the figure, it is simply that if you accept the offer, you will be having the EMV of $2 million. But if you reject the offer, you would still have the 50% chance at nothing. So again, utility theory is a utility assessment that assigns the worst outcome a utility of 0 and the best outcome a utility of 1. And a standard gamble is used to determine the utility values. So when you are indifferent, the utility values are equal. So looking at the standard gamble figure, you can see that expected utility of alternative 2 is equal to expected utility of alternative 1. And the utility of other outcome is equal to P multiplied by utility of best outcome, which is 1, plus 1 minus P multiplied by utility of the worst outcome, which is 0. So utility of other outcome can be calculated using the formula of P times 1 plus 1 minus P times 0. A utility curve is a graph that plots utility value versus monetary value. Once utility values have been determined, a utility curve can be constructed. And by that, you can determine that a risk avoider gets less utility from greater risk, whereas he or she avoids situation where high losses might occur. As monetary value increases, the utility curve increases at a slower rate. And a risk seeker gets more utility from a greater risk. As monetary value increases, the utility curve increases at a faster rate. So, someone who is indifferent will have a linear utility curve. This figure, it illustrates a person who is a risk seeker that has an opposite shaped utility curve. This decision maker gets more utility from a greater risk and higher potential payoff. As monetary value increase on his or her utility curve, the utility increases at an increasing rate. A person who is indifferent to risk has a utility curve that is a straight line. The shape of a person's utility curves depends on the specific decision that is being considered, the monetary value involved in the situation, the person's psychological frame and of mind, and how the person feels about the future. It may well be that you have one utility curve for some situation and completely different curves for the others. Moving on to utility as a decision-making criterion, once a utility curve has been developed or determined, it can be used in making decisions. And monetary outcomes or values are replaced with the appropriate utility values, and the decision analysis is performed as usual. And the expected utility is computed instead of the EMV. Let's say, for example, Mark Simkin loves to play gumball, and he decided to play a game that involves tossing the thumbtacks in the air. If the point of the thumbtacks is facing up after it lands, meaning Mark wins $10,000. But if the point of the thumbtack is down, Mark loses $10,000. So, should Mark play the game or should he not play the game? So, as you can see on the figure, alternative 1 is to play the game. Mark believes that there is a 45% chance of winning $10,000 and a 55% chance of suffering the $10,000 loss. And on the alternative 2, it is not to gamble. So what Mark should do? Of course, it depends on Mark's utility for money. As stated previously, he likes to gamble. So using the procedure just outlined, Mark was able to construct a utility curve using his preference for money. Mark has a total of $20,000 to gamble. So he has constructed the utility curve based on a best payoff of $20,000 and a worst payoff of $20,000 loss. And as you can see on the utility curve, we see that Mark's utility for $10,000 is 0.05. His utility for not playing is 0.15, and his utility for $10,000 is 0.30. So as you can see on the figure, alternative 1 is the best strategy using utility as the decision criterion. If EMV or the estimated monetary value had been used, alternative 2 would have been the best strategy. So the utility curve is a risk-seeker utility curve, and the choice of playing the game certainly reflects this preference for risk.